So in this video, I'm going to discuss the some of the properties of parallel lines. So I'm going to talk about one postulate and four theorems. So these are some of the postulates and theorems we will be using to solve some of the problems related to parallel lines. So let's look at the first postulate here, postulate 15, where it talks about corresponding lines, right? So all it is saying is that if you have two parallel lines like this, if these two lines are parallel and this line is cut by a transversal, as we see a transversal here, um, the angles form, or the relationship between these two angles form here, like angle 1 and angle 2. These are corresponding angles because the transversal cut each of the parallel line at these forming these angles here at the corresponding place. So these two angles are corresponding angles. And according to this postulate, these corresponding angles are congruent, or the measures of these angles are the same. So that is what congruence means. Angle 1 is congruent to angle 2. It means the measure here is the same as the measure here. And that is so because these two angles are corresponding angles because this transversal cut two parallel lines. Now let's look at theorem number 3, 4, which talks about alternate interior angles. These angles 3 and 4 are alternate interior angles. We know that if we have two parallel lines, these two lines are parallel, and we have a transversal, these angles on the inside here are interior angles. Alternate means it's alternates on either side of this transversal, and it's on the interior. So alternate interior angles are on the inside of the parallel line and on alternate sides of the transversal. And these angles are congruent. So that is the alternate interior angles theorem for parallel lines. They are congruent. Then the next theorem we look at is theorem 3.5, which talks about consecutive interior angles. These angles are interior here, 5 and 6, but they're not on the alternate side, they're on the same side. These are also called same side interior angles. And these angles are supplementary, meaning that the measures of these angles add up to 180 degrees. So it means then angle 5 plus angle 6 is equal to 180 degrees. That's the theorem for consecutive interior angles. So consecutive interior angles, if these are two parallel lines, this are two consecutive interior angles, and also these two over here are consecutive interior angles. They're not congruent, but they add up, they're supplementary, they add up to 180 degrees, right? So let's look at alternate exterior angles, similar to alternate interior angles, only this time they're on the outside. These angles also are congruent, and that is the alternate exterior angles for parallel lines theorem. Once parallel lines are cut by a transversal, then the pair of alternate exterior angles are congruent. And finally, we want to talk about the perpendicular transversal. So all this is saying that if you have two parallel lines and one of these parallel lines are cut by a perpendicular transversal, then this angle here is also perpendicular to the other parallel line. So if a transversal is perpendicular to a parallel line, then it's perpendicular to both of them. So those are the theorems, or some of the theorems we've been using to solve some of the problems for this chapter.